Okay, this video is about, well, there's 4 types of angles that we have in circles, and this video covers 2 of the 4. So the first type is a central angle, and a central angle is formed by 2 radii, and then the vertex is right here on the center, okay? But when it's a central angle, the vertex is on the center. Okay. For all these problems, we're going to keep asking ourselves where the vertex is. And based on where the vertex is, will allow us to figure out what the angle is. So on this one, let's just make sure we know what we're talking about when I refer to different things. This right here is the vertex. This right here is the angle. And this right here is the arc. So I'm going to be using these 3 words constantly, and you need to know which part I'm referring to. So when the vertex is on the center, so the first thing you're going to do is look at the vertex location, and then that will give you the formula. And the formula uses the angle and the arc. So when the vertex is on the circle, the angle equals the arc. So you can see the angle's 80, the arc's 80. It's a direct match. That one's pretty straightforward. The second place the angle can be, or the vertex can be, vertex on the circle. Okay. Now, if you look at this picture right here, when the vertex is on the circle and the sides of the angles are formed by 2 chords, this right here, this one, is an inscribed angle. This one over here, the vertex is still on the circle, but we've got stuff outside, so it's not inscribed. But the reason they put these 2 pictures together is because the vertex is still on the center, and no matter what the picture is, excuse me, not on the center, on the circle, and no matter what the picture is, the formula is going to be the same. Okay, so if we're looking at our picture, this is the vertex, this is the angle, and then this is the arc. Okay, so again, if you're looking over here, this is the vertex, this is the angle, and this whole thing in here is your arc. Okay, but no matter what the picture looks like, there's lots of variety. When the vertex is on the circle, the angle is going to equal 1/2 of the arc. Okay, so let's try a couple examples. So if we're looking at this first one, number 1, we're trying to figure out what x is. So we're going to ask ourselves, in this angle right here, where's the vertex? And it's on the center. So what's on the center, the angle equals the arc, and this is just 160. Okay, over here, we're going to ask ourselves, where's the vertex? The vertex is on the circle. And when it's on the circle, the angle, which is 100, equals 1/2 of the arc, which in this case is x. So to solve, we're going to multiply both sides by 2. So we get 200 equals x. Now, could you have done that in your head? 100% yes. And if you can, just write down the answer and go. I'm showing you the formula because it's going to be helpful for the next lesson. Okay, if we look at this third one, actually there's, I lost my train of thought. Oh, there's more information than we need. Okay, so if I want to find x, x is right here. The vertex is on the circle, so we know it's going to be 1/2 of the arc. But with all these lines, it's confusing. So if I extend the lines of my angle, this right here is the arc. Okay, and I didn't tell you earlier, but this arc is called the intercepted arc. Okay, so to be able to find x, we know that x is going to be 1/2 of the arc, and that arc we now know is the intercepted arc, and 1/2 of 136 is 68. So this angle here is 68. Well, so is the other one. And the reason they put this on there is it helps us to explain a rule. If 2 angles, we have a green angle and a blue angle, have the same intercepted arc, then the angles are congruent. So if you recognize that, you don't have to do all the work, and you can just say that's 68. Okay, let's look at these, and we'll do some more of these. This was not drawn great, but there we go. Okay, we need to find all the angles in the arcs. Well, if this central angle is 64, this arc, whoops, has to be 64. And if this central angle is 52, this arc is going to be 52. Because we have a central angle, the vertex is on the center, the angle and the arc match. Okay, so now what we're going to do is we're going to find some of the missing angles and arcs. But what we need to look at to help us is semicircles. So I'm going to look first at this semicircle. Semicircles always add to 180. So if this piece is 52, to get the other one, I'm going to do 180 minus 52, and that gives me 128. I'm going to erase the highlight so it doesn't get confusing. So that arc is 128, and that arc is 128. Okay, we also know these two angles here are vertical angles. Vertical angles are congruent, so that must be 52. So the arc must be 52. Okay, we've got one more we need to find, but good news for us, we've got another semicircle, right? And all three of those would have to add to 180. When doing these problems, find semicircles. So I know that 180 minus 52 minus 64 is going to also equal 64. So this is 64 and that's 64. Okay. So now we need to find x. So on the first one, just more practice, the same thing. The vertex is on the circle. So when it's on the circle, the angle and the arc match. So that means that x has to be 160. Nothing to it. Okay, on the next one, the vertex is on the circle. So when it's on the circle, the angle, which is 70, equals 1/2 of the arc. So to solve, we'll multiply both sides by 2. So we get 140 equals x. Over here, this is a central angle, so this angle is going to match this intercepted arc. But we weren't given that. But I know that this red arc and the rest of it form a circle, and a circle adds to 360. So if I do 360 minus 230, I'm going to get 130. So this arc right here is 130, and because it's a central angle, that angle is 130. Now 3 is a central angle. Going back to 2, this one was not a central angle, it was inscribed. That's why formula is different. Okay, let's look at number 4. Well, we can recognize that this is an inscribed angle because it's formed by two chords and the vertex is right here on the circle. This is also an inscribed angle and has the same intercepted arc. So we know they're equal, but we're trying to find the intercepted arc. Well, we can work with the blue one or the green one. It doesn't matter. It's going to be the same thing. But no matter what, our angle is going to be 1/2 of the arc. For these inscribed angle problems, the arcs are always bigger than the angle. So I'm going to multiply by 2. So I get x equals 104. Okay, on number 5, right here, this vertex is on the circle. So when it's on the circle, the angle, which is 165, is 1/2 of the arc. So to solve, multiply both sides by 2, so we get 330 equals x. But 6 is different. 6, the vertex is on the center, and when it's on the center, the angle and the arc match. This is 63. Done. Okay. Let's look at number 7. They're doing one of those problems where we define the missing angles and arcs. Now, it only asks us to find x, y, and z, but we're just going to fill in all of it. If this central angle is 70, this arc is 70. If this central angle is 55, this arc is 55. Okay, let's see what other angles we know. Well, because we have vertical angles, this has to be 70. So this is 70. Now we're going to start looking at semicircles. This is 1/2 a circle, which means that it adds to 180. So if I do 180 minus 70, I'm going to get 110. So if this arc is 110, the angle is 110. Okay, now I need to try another semicircle to be able to figure out z. These 3 form a semicircle, so they have to add to 180. So if I did 180 minus 70 minus 55, that gives me 55. So this is 55. So this angle here is 55. All right, let's see what happens on number 8. This is on the circle. So the angle, which is 110, equals 1/2 the intercepted arc. So when the lines go out, the intercepted arc is this one. So it equals 1/2 of x. So I multiply by 2. So x is 220. But we still need to find y. But the red arc and the yellow arc form a circle. So if I do 360 minus 220, I'm going to get 140, and this arc right here is 140. Hey, let's look at number 9. The vertex is on the circle. So when it's on the circle, the angle, which is x, is 1/2 of the intercepted arc, which is 48. And half of 48 is 24. Okay, number 10, vertex on the circle. So the angle, which is x, is going to equal 1/2 of the arc. So x equals 140. Remember, when you're doing the inscribed angles or the angles where the vertex is on the circle, either one, when you do those, the angle is always half the arc. So the angle is going to be smaller than the arc every time. So whether that kind of help you figure out whether you need to divide by 2 or multiply by 2. All right, number 11, we know this angle has to be 48, and we know that because these two angles have the same intercepted arc. And now we can find y, because 48 is an inscribed angle, and when it's inscribed, it equals half of the intercepted arc, which is y. So when I multiply both sides by 2, then I get y equals 96. Last one, we're going to fill in the numbers. X has to be 40 because that's a vertical angle. So we know these two arcs are 40. Okay. Now I'm going to look for semicircles. Here's a semicircle. So these two have to add to 180. So if I do 180 minus 40, I get 140. So this is 140. Over here, I've got another semicircle. So just like the last one, this one has to be 140 as well. Okay, make sure that you have completed these notes and the homework before you come to class next time.